Hello everyone, I am Seshavidya, working as Associate Professor in the Department of ECE at R.M.K College of Engineering and Technology. Now we are going to design off-subtractor. So off-subtractor is a combination circuit so that can be used to subtract one binary digit from the another. So which will give you the two outputs, one is difference, other one is borrow output. So that borrow output, it depends on, that is it specifies the whether that one has been borrowed to perform the subtraction. So based upon that we will have the borrow. So this is the block diagram of off-subtractor. So which will have two inputs that has to be subtracted and which will have the output difference D and borrow out. Now based upon this inputs and outputs, we can able to construct the truth table. So inputs, there are two inputs A and B that has to be subtracted, and output difference and borrow out. So to construct the truth table, we can just that is consider the operation table. So according to this operation table, for the subtraction, if it is 0 minus 0, then the difference is equal to 0. Suppose if it is 0 minus 1, then difference is equal to 1, borrow is also is equal to 1. Suppose if the bits are 1 minus 0, then difference is equal to 1. Suppose if it is 1 minus 1, then difference is equal to 0. So by using this operation table, we can able to let us construct the truth table. So first we can just write that input variables. So A and B, there are two input variables. So we know that which will have the four combinations of input combination, that is 2 per n. By using that formula 2 per n, where n is nothing but number of inputs. Since it has two inputs, so 2 per 2 is equal to 4. So it will have the four input combinations, that is 0, 0, 0, 1, 1, 0, 1, 1. Now we can just write that bits for difference as well as borrow out. So we can just perform the subtraction manually. 0 minus 0, as I told you from that operation table, difference is 0, borrow is also 0. If it is 0 minus 1, so 0 minus 1 is both difference as well as borrow out is equal to 1. 1 minus 0, so difference is equal to 1, borrow out is equal to 0. And here this 1 minus 1, obviously difference is equal to 0 and borrow out is also is equal to 0. So likewise you can able to construct the truth table. So next to this truth table, by using that K-map, you can just find out the simplified Boolean expression. And that the type of the K-map that has to be used is based on the number of inputs available in this truth table. So how many number of inputs according to this off-subtractor? Two input variables. So obviously we are going to use two input, that is a two variable K-map. By using the two variable K-map, we can able to find the simplified Boolean expression. In the K-map, so we can just group that min terms. So here we can just group that once. So this is this has one single group and this is also the another group. Similarly for the borrow. Now for this group we can just write the min term. The left hand side is nothing but the variable A. So this is equal to 0. So as I told you, A is, that is 0 is nothing but which will represent the complement of the variable. So A bar, and topmost variable is nothing but that is bit is equal to 1, which corresponds to the variable B. So therefore the B. So A bar B. So for this group it is A bar B. And for the second group, similarly we can write it min term. So left hand side the bit is 1, which corresponds to the variable A, and topmost bit is 0, which is nothing but complement of the variable. So that variable corresponds to B. So therefore it is B bar. So A B bar. So A B bar. So A B bar plus A bar B, we know that it's an XOR gate, that is XOR operation. So we can write it as A XOR B. Similarly, we can just write it for borrow. Since it has only one group, so the left hand side is it is 0. Again, it's nothing but complement of the variable. So therefore A bar, and topmost bit is 1, which corresponds to the variable B. So therefore A bar B. So borrow out is equal to A bar B. Now this is the simplified Boolean expression for difference as well as borrow out. Now we can just construct a logic diagram by using that logic gates. So since it is difference is nothing but A XOR B, so we will be using that XOR gate straight away. So inputs are A and B. So difference D is equal to A XOR B. And what is it borrow? Borrow is nothing but A bar into B. So since it is A complement, so we have to use one NOT gate here. So from A input, one NOT gate is connected. So therefore the output of this NOT gate is A bar. So that will act as one of the input of AND gate. So in similar way, B is connected to the other input as, that is other input of AND gate. So therefore the borrow out is nothing but A bar B. So likewise we can just draw the logic diagram. So this is a design of subtractor. We are going to discuss design of full subtractor. So this full subtractor, it consists of three inputs, that is A, B are the inputs that has to be subtracted. and the third input is nothing but borrow in. And as usual, output is nothing but there are two outputs, one is difference, the other one is borrow out. Now, as this input and output variables are identified, and we are just given that notation for that both input variables as well as output variables, now we can just construct the truth table. So as I told you, we can just remember that operation table. So this is the operation table for the subtractor. 0 minus 0, 0. 0 minus 1 is difference 1 as well as borrow is also is equal to 1. If it is 1 minus 0, then difference is equal to 1. If it is 1 minus 1, then difference is equal to 0. So by using this subtractor operation, so we can just write the truth table. So according to this full subtractor, we know that there are three inputs A, B, B in, that is borrow in, and outputs are nothing but difference D and borrow out. So first we can write that input table, that is the input combination. Since there are three input variables, so as we know that if there are three input variables which will have the 8 combination, that is the formula is 2 power n, where n is equal to number of input variables. So which will have the 8 input combinations starting from 0 to 7. So 0 in terms of 3 bit and 0 to 7 we will be writing the binary in terms of 3 bits equivalent. Now we can just see that what's the difference in borrow out from the operation table. So first one is 0 minus 0. So all three inputs are 0. Obviously difference is 0. Borrow is also 0. And second combination is 0 minus 0 is 0. 0 minus 1. We know that 0 minus 1 is difference is 1 and borrow is also 1. Similar way, again it is 0 minus 1. So obviously difference is equal to 1. Borrow is also is equal to 1. Now here it is 0 minus 1. Again it is minus 1. So it is nothing but here it is, there isn't borrow out. So difference is equal to 0. But there will be a borrow out. So that is equal to 1. And again it is 1. So obviously difference is equal to 1. Borrow 0. 1 minus 0. Again it is nothing but 1. Again 1 minus 1 is 0. So both difference as well as borrow out is equal to 0. Again the next one is 1 minus 1. Obviously 0. So difference is equal to 0. Borrow is also 0. If there are three inputs, that is 1 minus 1 is 0. 0 minus 1. So 0 minus 1, as we know that both difference as well as borrow out is equal to 1. So likewise we can construct the truth table for the full subtractor. Once it is constructed, we can just use that K-map to find out the simplified Boolean expression. So we can just select that the type of the K-map, that is whether it is 2 variable or 3 variable. It's based on the number of inputs used. Now in this full subtractor, there are 3 input variables, so that we can use that 3 variable K-map. So for the 3 variable, we can just use it 3 variable K-map. One is for difference, the other one is for borrow out. So for the difference K-map, we can just represent that wherever that difference D is equal to 1, the corresponding combination that can be represented as 1 in the K-map. That will be the next step. So for difference as well as for borrow, so we'll be representing that ones. And here also will be representing. And next to that, so we'll be grouping that ones. So all the single one as a group, and this is second group, third group, fourth group. So this K-map which has 4 groups. And this K-map, so this 2 as a group, this 2 as a group, and this 2 as a group. So which will have the 3 groups. So from each group we can able to find what is the min term, the corresponding min terms. So we can, since it has 4 groups, so we'll be having 4 min terms here. Since this borrow K-map, it has the 3 that is 3 groups. So we'll have the 3 min terms. So finally you can just write it in terms of sum of product term. So this is a Boolean, that is simplified Boolean expression for difference as well as for borrow out. Now by using that basic logic gates, we can able to draw the logic diagram. So the first one is representing, it's in difference logic diagram, and this is for borrow out. Since this difference expression, it has 4 min terms, so that we'll be using 4 AND gates here. Finally we are just adding together by using that OR gate. Similarly borrow out, it has 3 min terms. So the 3 min terms, so that we are using 3 AND gates here. Finally, all min terms are added together by using OR gates. So this is a simple logic diagram by using that logic gates. There is one to implement this full subtractor, and that's nothing but that is implementation of full subtractor using 2 off subtractors. So for that, what you have to do is, so we have to simplify that expression. So first we will be considering the difference equation. So here, so taking that common terms and simplifying this one, we'll be getting it as B in, that is borrow in XR A XR B. So this is a simplified Boolean expression. So as to implement the full subtractor by using 2 off subtractors. Similar way, borrow out also simplified in such a way that A bar B plus B in A bar B plus A B bar. So A bar B plus A B bar, we can write it as A XR B and whole complement. Or we can just write it as X naught. That is also correct. So this is the simplified Boolean expression for bar out, and this is the simplified Boolean expression for the difference. Now we can just implement the full subtractor using two off subtractors. If you just look into this diagram, this is one off subtractor, this is the another off subtractor. And finally we'll be adding one more R.K here. Now this output is nothing but difference, which will give you this expression, this one, that is B in XR A XR B. Similar way B out. So which will give you that simplified expression here. Thank you all.